Hello students, in this video we'll see an example of finding a probability density function and using the probability density function to compute a probability of a continuous random variable. Let's suppose that x is a continuous random variable whose PDF is proportional to f of x is the function x times 4 minus x for x between 0 and 4, and 0 otherwise. Let's find the probability that this random variable x is bigger than 1. So we know that this function, f of x, is the probability density function for the continuous random variable x. We also know two things about PDFs. We know that PDFs have to be bigger than or equal to 0. We can check this. It's clearly 0 over here. That's fine. Now, if x is between 0 and 4, this x is always positive. And if x is between 0 and 4, this 4 minus x is also always positive. So multiplying two positive numbers over here, so this is always positive in the range between 0 and 4 proper. So the only other thing we need to check is that its integral over the entire real line integrates to 1. We also need that the integral over the entire real line is 1. Now, most of the time, this function is 0. The only time this function is non-zero is between 0 and 4. So for us, this amounts to showing that the integral from 0 to 4 of some constant k, a constant of proportionality, times x times 4 minus x dx has to be equal to 1. This will allow us to find k. Now, I can pull that factor of k out. So this will be k, the integral from 0 to 4 of 4x minus x squared dx, which is k. And then we'll have a 2x squared minus x cubed over 3 from 0 to 4. And if we plug this in, we'll have a k times, if I plug in 4 to this, I'm going to have 16 times 2, that's 32. 32 minus, I plug in 4 cubed is 64, so I'll have 64 over 3. Now I can write 32. So we know that k times 32 is the same thing as 96 over 3 minus 64 over 3 has to be equal to 1. And so what this simplifies to is this is going to be a 32 over 3. So k times 32 over 3 is equal to 1. And that tells us that this constant proportionality k is exactly equal to 3 over 32. So I now know what k is. So the PDF, the real PDF, is going to be 3 over 32 times this quantity over here. Now, we wish to find the probability that x is bigger than 1. So let's do so. So now, the probability that x is bigger than or equal to 1, say bigger than or equal to, doesn't matter for continuous random variables, is equal to the integral from 1 up to 4 of k, which is 3 over 32, times x times 4 minus x dx. So again, what we can do is we can pull out that 3 over 32. And then we're going to have a 4x. So when I integrate 4x, I get 2x squared. When I integrate negative x squared, I get negative x cubed over 3. And we see we're in the same position as last time. The same integration appeared again. So we're fortunate we can save ourselves a little bit of work that way, 1 to 4. Now we know that when we plug in 4, what we get is we get a 32 over 3. So we're going to have 3 over 32. And then 32 over 3. And now when I plug in 1, I'm going to get a minus what? Minus 2 minus a third. Minus 2 minus a third. And so what this is 3 over 32. And then what we have, this is going to be 32 over 3. And then this is going to be a 5/3. So I have to subtract off 5/3 from this. So we have 3 over 32. And then we have, that will be a 27 over 3. The 3's will cancel, and we'll get a final answer of 27 over 32. So 27 over 32 is the probability that this continuous random variable x is bigger than 1. Thank you very much.